This video is the continuation learning more about properties. Let's say I have a number 2 and I want to add it to 0. And firstly, we can tell that this is a numerical expression. And I want to evaluate, I want to find the final answer. So it will be 2. What about 100 plus 0? So it's still 100, right? So any number add 0 will still be that number. And we want to describe this process, and we give it a new name, which is additive identity. So the definition is adding 0 to any number, adding 0 to any number. The result will be the number. And one thing I want to point out is identity mean same. And let's say I want to let a letter, or I just want to use variable a represent any numbers. And I want to write a general form for this rule. So it's going to be a plus 0 and equals 0 plus a. So equal a, which means a plus 0 will still be the 0. I mean a. And 0 plus a will still be the a. And I want to box it. For example, right? This pretty simple, right? 2 plus 0 will still be the 2, the number. Now, if I want to use 1 times 100, so it still be the 100. What if I use 100 times 1, it still be the 100. And so 1 times any number will still be the number. And I want to describe this process, and we give it a new name. We call it multiplicative identity, which means multiplying any number by 1. The result will be the number. And I want to use the general form to describe it, but I don't want to write the variable represent something, and you guys know it, right? So a times 1 equal 1 times a and equal a. So a times 1 is a. 1 times a is still a. Doesn't matter the order. Box it. For example, a simple example, let's say 1 times 80 is still 80. And for third rules, I want to use 0 times 20. It's still 0, right? So 0 times every number, or any number, will still be the 0. And we call this process multiplicative property of 0, which means multiplying any number by 0, the result will still be the 0. And I want to use the general form to describe it. So a times 0 is equal to 0 times a equals 0. And I box it. For example, 0 times 127 still be 0. Doesn't matter how large the number you multiply by. But I want to remind your guys that this process, this concept is really, really important. And you're going to see this throughout this algebra classes in a few semesters, maybe like 2 semesters or 3 semesters. But this is really important, and you guys gotta pay some attentions on it. Simplify. Simplify means using properties that we just learned, using properties to make algebraic expressions look more clear, which means to, like, let's say we have this whole chunk of expressions. I want to make it shorter, look nicer, clear. So this process is called simplify. And we usually combine numbers. If we see uh, multiple numbers, we gotta combine it. Let's say we have x plus 10 plus 9 plus 100. Does that look too many numbers? So to simplify, we gotta add these three numbers together and to make it look shorter and simpler. So we call it simplify. And usually we don't like parentheses and we don't want to keep it. So let's look at a example right here. We have y plus 1 and we have a parenthesis around them, also plus 9. To simplify it, we have to break this parenthesis, and we want to combine these two numbers because we don't want these two, right? We just want one number at the end. That's why we call it simplify. We're gonna make this whole chunk shorter. But how do we do that? Remember we learned about associative rule, right? Associative property. It says a plus b plus c equal a plus b plus c, but the parentheses I want to put around it, around a and b, and it's still the same for if I put the parentheses around b and c. The result will be the same. Does that look similar for this general form, similar to this? Yes. And that's why I want to write the general form, because a, b, and c, they are variables. Because they are variables, the definition of variables means we can use variables to represent any quantity. Quantity means numbers or variables. So this represents this. And because this is associative property, I can rewrite it as this, right? So let's do that. I can write y plus 1 plus 9, but I put the parentheses around these two numbers. And for the order of operation, whenever we see the parentheses, we gotta evaluate to calculate the numbers inside the parentheses first. So y plus 10. And that's it. That's our final answer to simplify it. Does that look shorter comparing to this? Yes, because we have two terms. And for this original expression, we have three terms. It looks shorter and we don't have parentheses right here. Let's say we have another number practice. Let's say we have 2 and 3, two numbers. Since we see the two numbers, we gotta make it shorter, right? We're gonna use something to manipulate it. And we also see the parentheses. We don't want to see the parentheses at the end. So what do we do? Can we use associative property? Let's try it. Let's say we use associative property. We put the parentheses around y, 2 and y, and times 3. Does it change anything, right? It doesn't help to combine 2 and 3. But let me remind you, in the previous video, we learned about commutative property, right? The second rule. So a times b equals b times a. So it doesn't matter if we switch the order or not. The 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 result will still be the same. But why don't we change the order inside the parentheses for those two numbers? Let's do that. So 2 times 3 times y. And for this time, we can use associative property and to figure out the final answer, because we can put the parentheses around these two numbers and combine them. So 2 times 3 is 6, and times y. I can also rewrite this 6 dot y as, so it equals 6y. They are all the same, right? So 6y can be represented as 6 cross y, or multiplied by y, or 6 dot y. They are the same.